Hey guys, we're going to do a quick graphing inequalities example. So I'm just going to create an example of a linear inequality with two variables. Let's say, get my pen in here. Okay. Let's say I've got y is less than or equal to 2x minus 3. All right. So in order to find one solution that satisfies my linear inequality, what I can do is pick a value for x and plug it in. Let's say that x is equal to 4. So I'm going to plug in 4. 2 times 4 gives me 8. 8 minus 3 gives me 5. So I know that my y value, in order for this to be a satisfied inequality, my y value has to be less than or equal to 5. So let's say that my y value is 4, because 4 is less than or equal to 5. So I know that the point 4, because my x coordinate is 4, my y coordinate is 4. That's something that satisfies the inequality. In order to find something that does not satisfy the inequality, let's keep, so this does not satisfy the inequality on this side, let's keep x is equal to 4, but then when I get to the y is less than or equal to 5, I want to pick a value for y that does not satisfy this equation. So let's say that y is going to be equal to 6, because 6 is not less than or equal to 5. This is not a solution that satisfies. So the coordinate for 6 is not a solution. All right, so let's graph this inequality. Y is less than or equal to 2x minus 3. Remember, when we graph inequalities, we start with the y-intercept first, just like we were graphing equations. All right, so my y-intercept is -3, so I'm going to go down 3 on the y, and my slope, here's my slope. If I were to put this into fraction form, it would be 2 over 1. So that means my rise is 2. I go up 2 over 1, up 2 over 1, 2 over 1. And this is not perfect, but this would be my line. All right. Now, I know that this line is going to be a solid line because I have a less than or equal to sign. When I have a less than or equal to or greater than or equal to, because it's including, okay, that number, it's that including those values, I have a solid line. If my inequality was just less than or just greater than, it would not include the points on that line. So it would be a dashed line if that were the case. Okay. Now, in order to figure out my shading, I know that my y is less than or equal to this expression here. So if I'm talking about something that's less than, my y on my y-axis, less than would be down here. I would be going down on the y-axis. So all of this side represents where y is decreasing from that line. So this would be where I would shade. Okay. If I had a different sign, like greater than or equal to, I would be shading over here. It would change my shading. Okay. Or if I just had a less than sign, it would change, and I would have a dashed line instead of a solid line. Okay, so changing the signs changes the line, whether it's dashed or solid, and it also changes the shading. All right, let's do an example of a quadratic inequality. So let's say, and we're going to do this in vertex form. So let's talk about vertex form for a second. So vertex form is just a little bit of a refresher. Y equals A parentheses x minus h parentheses squared plus k. All right, and I'm going to come up with my example y. Oh, let me get my pen back here. Y is less than or equal to negative 1/2 x plus 2 squared minus 3. All right, so we know that in vertex form, the h and the k, that is my vertex. That is either my minimum point or my maximum point, depending on how my graph is opening up. Remember, the A also tells me if it's positive, then my graph is opening up. I have a U that's opening up. If A is negative, I would have an upside down U. It's opening downwards, okay? So in this case, I'm going to pull out my vertex, my H and my K. Note that the formula already has the negative in here. So my example has a positive. That must mean a double negative is happening. In order to make this a positive, a double negative is happening. So that means my H is negative. I have a -2 as my H. And in general, guys, you're always going to change. Your H will always be the opposite of what you see in the equation. Okay, so my H is -2. My K is -3. So that's my vertex. I also know that my A is -1/2. That tells me my graph is opening down. All right. So if I were to just kind of sketch this out real quickly, okay? If I were to graph this, move this down a little bit, 1, 2, 3. My vertex is -2, -3, and my graph is opening down. Okay, so something like that. Again, it's not perfect. This also tells me I don't have any zeros. I don't have any y-intercepts here, or not x-intercepts, I should say. X-intercepts here. This graph is not hitting the x-axis, so I don't have any zeros. I don't have any x-intercepts. And last but not least, in order to figure out my shading, whether it's outside of the U or inside the U, I can just pick a point and plug it in, and then figure out if it satisfies the equation or not, okay? So if I pick the point 0, 0, okay, and I plug 0 in for y, and 0 in for x, and I start to simplify this, okay, so again, 0 plus 2 is just 2. 2 squared is 4. Half of 4 is 2, but I've got this negative there, so I've got -2 minus 3. Now I've got 0 is less than or equal to -5. All right, so now let's analyze this. Is 0 less than or equal to -5? Absolutely not, right? This does not satisfy the equation. So 0, 0, this point does not satisfy my inequality. So therefore I don't have any shading out here. Rather, I would have shading in here. And what I can do is try to test out a point inside of my U, and it would satisfy. So that's how I know I would be shading in here. Okay, but you can test that out and try it out in your assignment.